Yes, we will do sizing for this cmos technology. That function is y equal to a plus b multiplied by c plus d bar. We have ratio for this sizing is 5 to 1.5. That represents a pmos region. That's for nmos region. That means this pull up and pull down. That means pmos and nmos. I will take back that you can draw this circuit from this function. It is easy. Just do spare it. That's because it's or. We know in nmos part it will be as a parallel or shunt. As you see, A is here and this part is here is parallel for each other. We do something for this portion. As you see, this portion is here and these two are in is or. That mean in parallel in nmos region. That's as you see in parallel, and in parallel that's in parallel will be in series with B. As you see, it is in series. So do reverse for P region and you will see that mean this in parallel but here in series, and all function all part in parallel but here in series, as you may see. So to do sizing, it's easy. Just take the path that have the maximum number of transistor. As you see, this path is a maximum number that have is maximum number of transistor. 1 2 3 4 5 3 transistor in P region and the 2 transistor on the path in NMOS region. So for PMOS region we have 3 transistor, number of transistor, and also we have ratio as you say 5. So WP over WL or P equal to 5. Now as you see, we have 3 transistor in P region, so we multiply 3 by 5 for each transistor, so it will be 15 15 15. We do sizing for this. Just do sizing now for this. It is 15 15, but there is 1 transistor, so we divide by 15. We divide 15 by 2 to find size of this, so it will be 7.5. So it will be 15 omega with P for D. So something for this C, A and P, B. Now to find the final value for sizing, just multiple for each transistor, I mean just multiple. Let's take for D, just multiple 15 omega P by the length that's given in question. That means 0.5. It will be equal to 3.75 0.75. That will be just right. By multiple by L you can find ratio. In final it will be 3.75 over 0.25 ratio. That will be ratio of D transistor. So we can write here 3.75 over 0.25. That's the ratio of this transistor. And this, it will be sum, because also we have 15, also the sum. Also in there is it will also be the sum, 3.75 over 0.25. but here it is 7.5. Just multiply it by 0.25 and you will get 1.65 over 25, 0.25. It will be a ratio of this transistor. Now we do sizing for PMOS region. Now let's do sizing for NMOS region. It is the same thing, that also will be same, but here let's do as you see in this pass, as we take the pass of the longest pass in PMOS region we was a 3 transistor, but here we have 2 transistor on this pass, so the number of transistor will be 2. As sum we do this, we have a ratio of 1.5, so omega n ln will be 1.5. Just multiply it, it will be 3. So we have 3 for this transistor, 3 for this transistor as a sum, because in parallel 3 for this transistor. So we have 3 for this transistor, so this in parallel for this, just divide by 2, it will be 1.5, or not divide, because the ratio of 1.5, this will be 1.5, but we multiple, but in this region we just have 1 transistor, so don't multiply it, it will be the same as the ratio of given in question, it will be 1.5. so do the sign in the same thing, just it will be omega n omega n omega n omega n. Just take for b now 3 omega n multiplied by 0.25, it will be 0.75. Just multiply also but by 0.25, it will give you the ratio of b ratio. So b will be 0.75 over 0.25. Something for this, and for this also, just multiple 1.5 omega n by 0.75, it will give you 0.3763. Just also divide by 0.25, it will give you the ratio of a transistor in NMOS region. A transistor 0.753 over 0.5. That's all, nothing else.